Let's now take a look at the variant data type. This is a special data type that actually can hold all the other ones, plus has a couple of special values that you can put into it. Since it is so changeable, it does have a lot of overhead, so we try to avoid it wherever possible, but there are some unique characteristics of the variant that we need to take a look at. The first example here I'm going to show you has to deal with concatenating strings and numbers together. For example, if I click on this, I get 1020. If I click on this, I get 30. If I click on this, I get 1020. Now let's take a look at each of these and find out what's going on underneath the hood. So we'll go ahead and stop the program and come back to design mode here and look at this example. What I've got underneath here is I've got some code where I've dimmed variant string 1 and variant string 2 as variants. It's a data type. And what I'm going to do is I'm going to have variant string 1 equal to 10 and variant string 2 equal to 20. But these are actually character values. They are strings. When I do this concatenation and put it into this label, I'm going to do variant string 1 plus variant string 2. Now what happens here is that Visual Basic, when it sees a plus sign, tries to add two things together. But it has to look at the data type, and it looks and it sees that these are both strings. So the add for two strings is basically concatenate these two together. So that's why the value came out to be 1020. In here, when I dim variant string 1 and variant string 2, variant string 1 is equal to the character string 20, variant string 2 is equal to the number 20. Remember, variants can hold either type. Now when I do the variant string 1 plus variant string 2, what Visual Basic is going to do this time is look at these numbers, look at each operand and say, well, one's a string but one's a numeric. It will then try to coerce the string, it'll force the string into a numeric if it can, so it can do addition. In this case, it can do that because 10 is a valid number. So that's why when we run the application, go ahead and bring this up again, that's why this one returned 1020, but this one returned a 30, because it actually did addition. So as you can see, it really can be kind of confusing when working with these variants here, because you got to keep track of the different data types that are in there and know whether you want to concatenate or whether you want to add two things together. If you know you want to do concatenation, then you should always, no matter what you have as data types here, you should always use the ampersand to concatenate these two variants together. That's why what you'll see in most VB programs, you will see the concatenation always used to concatenate two strings together. This just helps you distinguish what's going on and that you know that you're doing concatenation and not addition. Now the other examples here show you how to figure out what is in a data type. There is a special function called var type. So here I've assigned mVariant var equal to hi there, which is a string. So if I pass mVariant var to this var type function, what this will do is it will calculate and look into the variant and determine what type of data type it is. In this case, it's a string, so it returns to me a certain number. Then when I look at this example, and I've got mVariant var equals 10, in this case, when I do the mvar, or the var type on that mVariant var, it looks in there, it just sees that it's got a 10, and it reports back that this is an integer data type. Let's go ahead and run this application again. And in this case, it reports back an 8, which means that it's a data type of string. And in this case, it reports back a 2, which means that there is a variant type of integer. And in the keynotes, there's a nice table showing you all of the different values for these different variant var types that can be returned. There's also a couple of other special types called empty and null that can be put into the variant data type. Let's now turn our attention to arrays. Arrays are basically a group of elements actually stored under a common name. So you're going to create one variable name, but that variable is going to be able to store many values. Kind of like post office boxes. You can go to the post office and you see a row of post office boxes. You know which one's yours because it has a certain number on it. Well, that's exactly how we're going to access an array with a certain number. We're going to use it as a subscript, that is an index, into this array name. So let's take a look at some different values that you can use with arrays. The first example, we'll talk about fixed size arrays. If we look at the code for this, what I have done is I've created a global array of strings called Social Security number. Now you notice how I can access each of these individual elements here by using a subscript on this. So basically I've got a global array, and in element 0 I'm going to put this string, in element 1 I'm going to put this string, and in element 2 I'm going to put this string, and in element 3 I'm going to put this string. Well, let's go over and take a look at the declaration for this particular variable. We'll go over here to the project window, and we'll bring up this one here, and you'll see right down here, public GASTRSSN subscript 3 as a string. By using this nomenclature, you have told Visual Basic to make an array of 4 characters. The reason why is arrays in Visual Basic start at 0. So this is 0, 1, 2, and 3 elements that you put into this GA string SSN. I've also created a couple of other global arrays that are also of size 4, and one happens to be declared as the type of currency. Now, since you've declared these two as strings and this one as a currency, the only thing that can go into each of these elements are those data types. So the only thing that can go into here are currency values, and into this you can only put string values. If we go back to the other code now, back over here, you can see all of these examples where I'm putting things into these different arrays, and here's the one that's actually going into the currency values here. So that's how you assign information into each of the array elements. Now if we move down a little bit, you can see that we can just print these out right onto the form. Me, remember, refers to the current form, so I can clear the form. I can then do a print method on the form to actually print out the Social Security number, the name, and then, of course, the salary itself. So if we were to run this example, when I click here, you will see that all of those values have now come out onto the form. So that's how you create, set up fixed size arrays. These are fixed because they are basically only allowed to be this one size throughout the life of the program. Now the other type of arrays that we have are called dynamic arrays. And so let's look at our example for creating dynamic arrays. Dynamic arrays you can actually create at runtime. Here I have declared an int size as an integer and just assigned it to 3. Now this is a hard-coded example, but this might be that you pass this in or you get this from a user. How many elements do you want to set up? Now what I'm going to do is I'm going to use the redim statement. This is actually an executable statement. And when I redim something, it says redim something to this new size at runtime. And I'm declaring this one as a Boolean. Now, again, what we might want to do is look at this example. I'm going to go ahead and split the screen here. I'll show you how to do this a little later. Let's go to the General Declarations area. And you can see that I have dimmed MA bool bonus, open paren, close paren. Now that tells Visual Basic that this is going to be an array type, but that we don't yet know the size for this particular array. And then down here, we use the redim statement to actually tell it what the size is going to be. And again, since I made it int size of 3, that's 4 elements that can actually go into it. So we can assign those values, and then of course we can then print them out, as you can see there. So that's how you set up dynamic arrays. Our next example is redimming something again after you've already put information into it. So obviously I've already created this dynamic array, and now what I'm going to do is I'm going to do a redim preserve MA bool bonus subscript 4, because what I want to do is I want to add on one element. Well, if I didn't have this keyword preserve here, what that would mean is that it's now going to create a brand new array for me. Well, that wipes out the values that I had before. That's not really what I want. So by putting the preserve keyword in here, what Visual Basic does is it creates a new array in memory, copies over the values of the old one, and it actually then has one more added on to it. We can then assign the new value, and then we can once again print out all the new values, and you'll see that all the other ones were preserved. If we run the application and we click on Dynamic, you'll see over here that it has brought out true, true, false, and false. If I then click on Preserve, when I look over here, it now has true, true, false, false, and true. So it did maintain the old values and added on one for us. There are some miscellaneous things you can do with arrays. Let's take a look at some of the additional things you can do with arrays, as well as multi-dimensional arrays. Let's talk about some of these different options you have. What I've got here is another BAS module called array.bas. And one of the things I've added to the top of this module is option base 1. Now this is another option that you can tell Visual Basic that everything within this particular BAS module or class module or form module, when you create an array, if you don't specify a bounds, will actually always start with 1. So you can have option base left off, which means all arrays start at 0, or you can specify option base 1, which means all arrays will start at 1. Now, in lieu of that, you can also physically declare or explicitly declare that you want an array to be from 1 to 5, or you may even want to model something in the real world, so you may want to have the numbers go from 50 to 100. Now, this is still just 50 spaces in the array. It's just that the numbering starts at 50 and goes to 100. I've also got I've got an array topics. It's just a little subroutine where I dim VNT names as a variant. Now by doing this as a variant, I could actually put multiple types of values into this particular array. So each element could actually be different. One could be an integer, one could be a long, and one could be a string. Now you'll notice that I have not used the open and close parens here. So that means that at this point, this thing is not actually an array. In fact, there is a function called isArray that you can actually pass a variant to, and it'll tell you whether it contains an array or not. So it'll return a true or false. Now I'm going to use this debug.print, which will actually print to the immediate window, and we'll show you that in just a second. Now what I can do is I can take that variant that I've got and assign it equal to the array function. Now the array function is for you to set up an array of however many values you want. You can pass 1 to n amount of parameters here. It doesn't matter how many you pass. And it'll create an array for you out of all of these different parameters. So once I've done this, I can then debug.print and print each of those values to the immediate window. If I now use the isArray function here, now it would return a true because variant names now does contain an array. A couple other things. There is an L-bound function and a U-bound, which stands for lower bound of the array and the upper bound of the array. Now, in this case, variant names, the L-bound will be 1 and the U-bound will be 4. Because remember, when I declared this thing, I had it in a module that said option base 1. Now, if I do an L-bound and a U-bound on MA string ports, basically what it's going to report back to me is 50 and 100, because as you remember, we declared that as 50 and 100 up here. And then the last thing is if you want to get rid of an array out of memory, you may erase that array. Well, what I'm going to do is I'm going to hit Control-G to bring up the immediate window here, and I'm going to call array topics. And when I call this, we should see all those values come out. The first value is false, meaning that variant names is not an array. Then it reports back all of the values that I put in using the array function. It then reports that variant names is true, that it is an array. The lower bound is 1, the upper bound is 4, and then the lower bound on the MA string ports is 50, and the upper bound is 100. Everything we've looked at so far has just been single-dimensional arrays. Well, you are allowed to have multi-dimensional arrays. In fact, you can have up to 16 dimensions. Now, I usually can't think anything more past 3, but let's take a look at a two-dimensional array just so you can get the syntax down. I have another example for these multi-dimensional arrays. What I've done is I have dimmed A variant employees 3, 2 as a variant. Now what this gives me is a 3 by 2 array, and you can see that what I have done is I've set up constants for each element. So what I've got is I say A variant employees 0, comma, and then 0, constant SSN. So the SSN is equal to this. Constant name is equal to Paul, and constant salary is equal to 100,000. Now what I've done is I've replaced the 3 arrays that we saw in the previous example with one array now. And this array actually has 2 dimensions to it. The first one, in effect, gives me the row. The second element then gives me the column, if you will, if we think of this as a table in memory. So the variant employees 1, comma, Social Security number, name, and salary is equal to these values. And then 2, comma, Social Security, name, and salary is equal to these values. So this makes it very easy to store different data types within one array by creating an array, a variant array that is multidimensional. Then, of course, what we can do is we could print out each of those values here just by, again, referencing the subscripts, 0, 1, 2, and 3, and then these elements here. Well, like I said, you're allowed to have more than 2 dimensions to an array if you want, and you just keep specifying a comma with a different number, and that'll give you your different dimensions.